Welcome to this alarm service demo video brought to you by IOTech. In this video, we'll demonstrate how our alarm service delivers a unified, standards-based solution for managing alarms at the edge. As a quick reminder, IOTech's alarm service provides a comprehensive and unified approach to alarm normalization and management. It is technology agnostic, which ensures it can handle and manage alarms from a whole range of different operational technologies. The solution is built on well-established industry standards like OPC-UA alarms and conditions, and is aligned with IEC 62682. Okay, so onto the demo. Here we're using an industrial controller that communicates over Modbus as our test device that will raise alarms for us to capture and handle. The monitored alarms include a deviation alarm for the temperature and a discrete alarm for the safety door becoming open. These examples show how various types of alarms can be identified and routed in real time. When we do the demo, a key point to keep an eye out for is the detailed state model that can be assigned to the alarms. Alarms can be confirmed, acknowledged, active or inactive, shelved, suppressed, and so on. It really is a rich interaction model. We'll demonstrate some of these different states in our demo here. A quick note about our demo today. We'll be showing the capabilities of the alarm service by interacting via its REST API. This is how you would be using the service to integrate into your own applications or user interfaces. We're also working on a dedicated alarms user interface ourselves, and we'll have that ready very shortly. Stay tuned for more videos of that. But okay, let's switch over to our test machine. First, we need to define the alarms that we would like to be able to raise, and that's done in a simple configuration file. So for example, here we can model two different alarm types, a deviation alarm relating to the value of the temperature recorded by the controller devices, and secondly, a discrete alarm which models the state of the safety door for the controller, which can obviously be open or closed. And you can see some of the details that can be modeled here, including standard set point levels and the specific values that warrant the different alarm levels. We can monitor high limit alarms, low limit alarms, and even things like high alarms, which represent critical alarms in the rich standard alarms model we're using. The attributes shown here are only a subset of what can be modeled. It really is a rich specification. So I've got Edge Central already started, and there is the alarm service Docker container. We have three devices created here, controller 0, 1, and 2, and you can see those all in the Edge Central UI here. As mentioned, the alarm service is based on OPC-UA, and we can use the IOTech OPC-UA browser to see all of the entities in the system. There are the three devices and all of the alarm information. We can subscribe to the alarm information here, and right now you can see there are no alarms because everything is stable. As mentioned, it's likely that a user would either use our dedicated alarms UI, which is in development, or they'd work against the comprehensive REST API. In this example, I'll use the REST API tool, Postman, to show how to use and query the alarm service. So you can see all of the available operations here on the left-hand side, but in particular, if I run the list alarms operation, you can see there are currently none. Obviously, the user interface would use this result to visually display any alarm information that was returned. So the next step is to raise an alarm. I can do this by simulating opening the safety door of one of the devices to trigger the door open alarm. If I switch back to Postman, I can now see that we have an alarm triggered. We've got rich information here, such as the name and resource of the particular device, and the current state of the alarm, which is active, but acknowledged as false, as you see. We can see how the information is also available in the OPC-UA browser here. So with the alarm set to active, the next step usually is for the operator to acknowledge that alarm. That is to say that they've seen it and are aware of it. There is a REST API for doing so. So we can do that in Postman like this, and add a comment. And then we can see that change if we get the state of the alarm again. Act is now set to true, along with our message. Let's now close that safety door, which will mean that the alarm should be reset. So if we close the door and run the alarm query again, we can see that the alarm information is persisted because we want to keep a history of all of the alarms, but that alarm is now no longer active. Good. It's use case specific, but you might then expect the operator to confirm that alarm, that is, verify that the alarm condition has returned to normal and they've taken any necessary post-alarm actions. So again, a REST API for that. We can do that here and see the result. Again, all of this will be typically handled in the UI, but you can see the rich information that can be presented. Okay, good. Next, we're going to show how an alarm can be routed. We're going to use Slack as a notification mechanism here, and also show a different alarm type, our temperature deviation. For an alarm route, we basically have to associate an action, in this case the Slack notification, with an alarm route, which is an alarm condition, together with the statement of when a route should be triggered. I've set that up already in our environment, so it should be active now. So now when I simulate a high temperature value on one of the devices, let's do a small increase as per our alarms config, say 86. We should see that the alarm service receives that data change, calculates the alarm, and then raises the specified action. And yes, we see the Slack notification arrive. It was a rise of 6 degrees, so it's described as a medium level alarm. And now if I go back and make the temperature jump by a bigger amount, say to 100, which is a jump of more than 10, that should equate to a high alarm and therefore come through as critical. Yes, there we go. And all of this information is also available in the REST APIs, of course. This is just an example of how an alarm can be handled and delivered to external systems. As you can see, the IOTech Alarm service is extremely rich and easily configurable by the user. Thanks for watching. For more information, visit iotechsys.com or arrange a one-on-one session with our team. Thank you.